Okay, now we're going to work on a lab talking a little bit about viscosity. We're going to talk about lubrication. We're going to talk about oils. So most things in industry are going to have to be lubricated in order to be able to continue to work, have a long enough surface life or service life. So the very first thing we're going to talk about today is viscosity, kind of what it means. Not going to get into a big lesson, but essentially it is the ability for the molecules to kind of flow around each other in a liquid. All right, so oil specifically, there's this big thing with SAE 30, SAE 50, 5W20. I'm not going to answer all those things today, but what I am going to do is talk a little bit about how something like that would be measured. So let's get into it really quickly. The first thing that we're going to look at here is we actually have a Zahn viscosity cup. Okay, this is not the only system to be able to measure viscosity. This is just one that is generally accepted by SAE, the Society of Automotive Engineers, and let's just talk a little bit about how it works. All right. So the first thing that we're going to need is obviously the cup. We're also going to need a stopwatch here, and then we're going to need some oil. Now, I already know what the viscosity of this oil is, or at least what it's printed on here, but I don't know exactly what it is. So we're going to just do this test, and we're going to go ahead and figure it out. Now, how we're going to do it is we're going to start by filling this up. And essentially, we need to put enough oil in here so that the cup becomes submerged. And it looks like I've been able to do that. Okay, so by putting this entire jug right here in there, I actually have my cup completely submerged. Now, how am I actually going to do the test? It's pretty simple. I'm going to make sure that this is cleared out, it's reset, and I am going to pick this up, and we're going to watch what happens. I'm going to push this as soon as I get this out of the oil. So 1, 2, 3. Now you can see here I have a steady stream out of the bottom of this cup. Yes, there is a hole in the bottom of the cup, and it is a specific size for the amount, the volume that's coming out of there. What I'm going to do is I'm going to watch very intently for when the stream actually breaks. The moment the stream breaks, I am going to stop this. A little bit longer. Try to keep it steady so that I don't mess with it. Right there. Okay, I have 31 seconds and 28 milliseconds. Now, that right there is going to give me the things that I need in order to be able to calculate what the exact viscosity is. Now, we have something here. Now, this particular cup, okay, the Zahn cup, this is the formula that we're going to be working with. We have V, which is viscosity. We have T, which is time. And this cup, okay, not any other cup necessarily, but it's going to be 11.7 times the time minus 87.8, and that's going to give us the viscosity. Now, I'm not going to give you the answers to this, okay, but rather this is how we're going to set it up. You're going to take 3 different time measurements, and then you're going to take the average. So getting the average is very simple. Time 1, time 2, times 3. We add those up, and then we divide that by 1, 2, 3, okay, and that's going to give us the average time. Once we get the average time, then we take the average time, multiply that by 11.7 and minus 87.8, and that's going to give us our viscosity.